The next talk will be by Zeki Seskir, and actually he's a very important person for us because he's working on the landscape of quantum information and quantum technologies in Turkey. So it will be a pleasure to listen to him, and I let the talk to him.
Thank you. Can everybody hear me? Really? Can you hear me, Emre Hocam?
Yes, I do.
Okay, so I will share my presentation. Is everything okay? Can you see it?
Yes,
okay.
I can.
Okay. So initially, I would like to thank everyone for staying here. I think it has been around 7 hours of presentations and it has been going very smoothly. I really want to thank the organizers and the chairs of this event because, I mean, for some time it was a little shaky whether we will have the event or it will be online, and it has been going really great. I really want to thank everyone for this. My work is, as Emre just said, actually not of quantum technologies, but on the academic literature in quantum technologies. And it is basically a collaboration between the physics department and the technology policy department. This is basically my outline. I will very briefly explain what is scientometrics, which is basically the field of studying the scientific literature. How did we collect our data? And then I will share with you my initial findings, which are very basic things and non-basic things as it emerges. And then I will talk a little bit about Turkey, what is going on, where are we compared to the general literature. And then I will conclude my talk. Okay, so what is scientometrics? I think all of you have heard these things, you know, Web of Science, Scopus, Google Scholar, H-index, impact factor, Q1, Q2, most of the things that make an academic's life hell. And it is basically the field that figures out those metrics. And the reason that we have this field is due to the one guy called Eugene Garfield. In 1955, he basically developed this thing called the citation index. And the reason that he developed this was to help libraries to decide which journal to buy and which journal not to buy. So it was basically a cost-cutting thing. And now it basically dominates the academia. And it is used widely for policy reasons as well. In this study, we have used the following keyword query. You can find this in the archive version of the study. And we used Web of Science to gather only the articles. We were not interested in proceedings, books, or other kinds of academic products, because published articles are they are basically robust. They went through the peer review process. And we found something like 50,000 articles in the June of 2019. The number is now around 55,000. So this is data. As you can see, it goes on and on and on. And if you structure it, it is still not nice. As you can see, it is rather lots of, let's say, lines in Excel. So how to make sense of this data? You need to use a couple of programs. Excel is your friend in, you know, structuring the data. There is this Python pandas package, which is useful for constructing data frames. You use PyEC for small visualizations of small networks. You use VosFever for larger networks, and you use Chi-square tools for some other things. We used it for burst analysis. Let's start simple. Let's start with the number of articles. There's this thing in chat, but I cannot see. Why can't I see the chat? Okay. Let's start with the number of articles. As you can see, the total number of articles is increasing rapidly, and it has been since the year almost 2000. And And then we check the average number of authors per paper, which is basically a metric on how collaborative is the field. And the red line here corresponds to the full list. If we limit the number of authors per paper to 50, we have this line. And if we limit it to 10, we still have this line, which means in all of the cases, co-authorship is rising steadily. And as you can see here, as of 2013, the mode of number of authors per paper is 3, which means the entire chunk of the literature here consists mostly of papers with 3 authors. Previously to that, it was 2, and as far as I can see from the data, it was never 1. So single author papers were never the dominating type of articles. And when you run a country level analysis, you see that China has most of the articles, which is closely followed by US, and then England and Germany and France and so on. And if you combine the entire Europe, and even if you exclude England because of Brexit, basically these 3 are almost on par. They have similar amount of contribution to the literature, which is around 30% for, or let's say 28 to 30% for each of them. And then if you look at the co-authorship analysis of the countries with more than 10 published articles, you can see basically researchers from which countries are collaborating with researchers from which other countries. You can see China here, which is basically collaborating with Middle East and with Korea and Italy, and you have the usual suspects. I think this is Singapore. For some reason, there is no name. And you can see Turkey here with India and Brazil and Mexico. And we did an institutional level analysis as well. And this is the top 12 institutions with publications in our data set. The thing about Chinese Academy of Sciences that we have to, we have to consider them in a special case, because this is basically 1/4 of almost entire literature in China, since not 20%, 25% of entire researchers in China are working in Chinese Academy of Sciences. This is due to the fact that most Chinese researchers have multiple affiliations, so that the numbers here is high. But this, I mean, this doesn't change that China has more than 1/3 of the literature. And again, if you run the co-authorship analysis for organizations with more than 150 published articles, you get this thing. Here you can see that the Chinese institutions are really close together. They collaborate internally much more strongly than their international collaborations. A similar thing can be said for Japan as well. And here you have basically the rest of the world. You have Europe here, US, Australia, and Canada. And Singapore is, of course, a very important country in our field. And you can see that it kind of forms its own cluster. And also Russia can be seen in here as another cluster. And then we followed this by looking at the keywords in titles and author keywords. And if 2 of the keywords appear together, they appear here with a line between them. And as the number of occurrence increases, the line gets thicker, and the number of occurrence of the term gets higher, the dot gets bigger. And from here, you can see that actually the literature can be clustered into 3 very dense clusters of keywords. I interpret this red part as physical realizations, not just experimental things, but basically solid state physics and physical realizations of theoretical concepts in our field. This blue cluster is more related to quantum optics and communication and cryptography. And this green cluster is more about computation and quantum information theory. But 200 is kind of a high number. If you lower that to basically increase your precision, you have something that is less clear, but you can see a fourth cluster beginning to emerge. And this cluster is basically more about theoretical concepts. Maybe quantum thermodynamics will emerge from here compared to the other clusters. And we continued with burst analysis in the field, which means that whether a topic is gaining attraction. And you can see here that with a lower density parameter, which means only big bursts can be seen, this is the field. And it starts with quantum computation, entanglement, quantum computer, teleportation, quantum computing, cavity QAD. For some reason, there's this huge entanglement boost here, and then it evolves as time goes, quantum correlations, Discord, and so on. With a higher density parameter, which allows you to see smaller bursts, you get 69 keywords. You can see the entire list in the archive version. And here, I just put the ones that are still ongoing, the bursts that are still ongoing. And I think you can remember this from Professor Communis's talk that quantum coherence is getting a really important place in the literature. And these are kind of usual suspects. I was kind of surprised by ADS-CFT, but then I talked with a couple of friends and they said that ADS-CFT is being used everywhere. So it's just, you should just expect it to be used in your field as well. And well, I didn't trust the software tools, to be honest, and I wanted to check it whether it holds. So this is basically frequency analysis. I use these three, and you can see that basically the bursts hold. I mean, you can see that these keywords are gaining attraction. I wanted to compare them with another keyword that is not gaining attraction, and it's quantum teleportation. And as you can see, it is kind of mainstream. It is just there. It's not bursting. It's not fading away. It's just around. And if you compare it with quantum computing, again, for some reason at 2009, it has a huge, let's say, increase. And then it went to normal. And you can see that these are very small compared to quantum computing. So what about Turkey? I ran the numbers of...
I'm sorry. Zeki, you have 3 minutes.
Okay, this is one of my last 4 or 5 slides.
Okay, thank you very much.
Thank you, Hocam. So about Turkey, you can see that, so you can ignore these parts because they are basic outliers. There were like 5 or 6 articles there per year. But in Turkey, we are collaborating less. In comparison to the international literature. The number of articles is increasing from Turkey, but it is not increasing rapidly enough to give a comparative advantage in the international literature. And our contribution to the overall literature, although it has increased, it is still around 0.4%, which is rather low for a country with 80 million people. And very quickly, the collaboration networks thing, this is from my thesis from Science and Technology Policy Studies Department. Each dot corresponds to a single author, and the size of the dot means that they have more papers in the literature. It doesn't necessarily mean that they have that much paper, but the number of papers in the data set that we have. And the networks doesn't mean that entire network is located in Turkey. For example, in this network, there's only a single author from Turkey. So the networks basically means that how internationally integrated you are. Most of the network from here are from Turkey. You can guess most of the people there. I compared it with South Africa, Portugal, and Saudi Arabia because they have similar metrics with Turkey in terms of GDP and population. And you can see that they are much, well, they're better stationed in international collaboration than Turkey. Turkey has a very sparse network collaboration map. You can just check this from the paper. We found 34 core articles or works of scholarly work that kinda is the core corpus of this entire field. As you can see, Nielsen Chang's book, it has the most of the citations, which is followed by Bennett, Eckert, Dusin, the EPR paper, and here in the highly cited works, it is Kimball's work, Walraff, Nayak, and Oradechki. They are the people that you can imagine. So what are the takeaway messages? The field is highly dynamic for the last decades. There are lots of new topics emerging, but it is not yet an established field. There is this rule called Pareto distribution, or the 80-20 rule, concerning the number of journals and the number of articles. The field does not fit to that distribution, which means that the field will still evolve. It is not an established field like nanotechnology. Also, the literature has been becoming steadily more collaborative for the last 30 years. There are 3 or maybe 4, depending on the precision, main clusters of research areas. There is no clear winner of this race yet. So Europe, US, and China are still racing. Chinese and Japanese institutions more heavily collaborate on national levels, but Europe and US, basically they collaborate on international levels more. So what about Turkey? Number of articles increasing, but not rapidly enough, and we collaborate less, and we are part of fewer large research networks in terms of international networks. You can see these 2 studies for the most of the things that I've used here, and you can just check us. I'm out of time, but you can check this work. And I want to thank you for listening, and I will, if you have questions, please ask.
We thank this Zeki one more time. Sorry, not one more time. This is the first time. And for this timely talk and interesting talk. If you have any questions, please raise them from question and answers part. Otherwise, I will move to the second.
Yeah, you can ask me.
Okay, there is a question, and Sevilay writes me, and from Granger. How can I take the question? I cannot see the question. Okay. For any scientific domain, some kind of saturation, stabilization in the number of papers is expected. Nothing like that here.
Yeah, the field is not established yet. I mean, the number of new articles is increasing every year, and it doesn't even fit the distribution of, the number of journals is not even established yet. So the field still has a long way to go before becoming a really established or saturated field. You can check those things by using certain metrics, like the distribution, and you cannot see them in the literature right now.
But it's Philippe Granger. Are there other examples of that? Like after it's, let's say, 20, 25 years, 30 years, we are still in a growing stage. Is it usual or not in bibliometry?
Usually the trend is that the number of articles is always increasing, but the number of articles each year at sometimes becomes kind of saturated for fields that are dying or fields that have become so mainstream. But this is a very new field. For example,
30 years, very new.
Yeah, it's really new compared to the other ones. For example, biochemistry is still considered an interdisciplinary field, but it has been around for decades, and it is kind of established. You can apply those metrics to here because it is really, biochemistry is something really studied in the scientometric groups because it's basically born out of chemistry, and you can actually see those things. Quantum technologies right now is really heavily dependent on physics journals. Like it has really only a couple of journals that are on top 12 now that you can see that it's the field's journal, like Quantum Information Science and Technology, and mostly the papers are published in Physical Review and PL, I think. No. But did I answer your question? Or
yes.
Thank you.
Is there any more questions? Okay. We thank
you.
Zeki again for his nice talk, and